There are also questions where we call them compound angles. Compound angle is something like this: sine x plus something. Something would be added or subtracted. When this happens, it's a compound angle. So let's do an example. Sine x plus 10 equals to 0.5. Remember, this whole thing is the angle. X plus 10 is the angle, and we call this the compound angle. So for convenience, let me call this theta. Sine theta is 0.5, so this is positive. So positive is first quadrant, all positive, and second quadrant, sine positive. Then the basic angle would be x plus 10 is sine inverse of 0.5. Sine inverse of 0.5, if you remember the common angles, so when we have sine inverse of half, that means 30 degree. So we have 30 degree. So the basic angle would be 30 degree and 30 degree. The common mistake is to break this down and find the value of x. So you write 30 minus 10, so x equals to 20 degree. This cannot be done because this angle is the basic angle and it cannot be broken down. So x plus 10 is the basic angle, and in the first quadrant it is the same as the basic angle 30. And again, x plus 10 is the basic angle, and in the second quadrant it is 180 minus 30, which is 150. So that's it. This is the sum. Now when you write down the answer, your answer has to be in terms of x. So it is only in the last line that you have to write down the value of x. So here x would be 30 minus 10, 20, and here x would be 150 minus 10, 140. So when you do a compound angle, then this is how you do the sum. Let's do another one. Suppose you have tan 2x minus 15 equals to minus 1. That means tan is negative in the second quadrant and the fourth quadrant. So this is tan negative because this is sine positive, and this is cos positive, so this would be tan negative. Again, the basic angle would be 2x minus 15 is the basic angle. Tan inverse of, remember, when we find the basic angle we take the absolute value, so instead of minus 1 we just take only 1, so that would be 45 degree. You can check from the most common angles, you should have this memorized. So for tan theta we get 1 in 45 degree, which is pi by 4 in radian. So we have horizontal line 45 degree here and 45 degree here. So 2x minus 15 is your angle. So the first angle here is in the second quadrant, which means 180 minus 45, which is 135 degree. Let me check. 180 minus 45 is 135 degree. And 2x minus 15 equals to, this is 360 minus 45, which is 315. So this would be 360 minus 45. So this is done. Now only at the answer, only now we can break this down. So 135 plus 15 divided by 2, we can calculate this. So we have 135 plus, if you send this 15 to the other side, it becomes plus 15, it becomes 150. Now if you send the 2 downstairs divided by 2, that would be 75. So the first angle would be 75. Then you have 315 plus 15, which is going to be 330 divided by 2, that is going to be 165. So these are the answer. So when you do a compound angle, remember, whatever the value is, sine x, sine 2x, sine 3x, if something is added or subtracted to that, it is called a compound angle. And in a compound angle you cannot break it down, you have to keep it like this. Now there is another thing called multiple angle. Multiple angle works similar to compound angle. but the difference is that whenever you have sine x, instead of sine x you have 2x. This is a multiple angle and nothing is added here. If something was added to this, that would be called a compound angle. So sine 2x is a multiple angle, or sine 3x equals to something, suppose equals to 1 by square root of 2, or equals to root 3 by 2, or suppose cos 2x is equals to half, or cos 3x equals to 1 by root 2, something like that. Whenever we have some number multiplied to the angle and nothing is added or subtracted, then we call it a multiple angle. The difference between multiple angle and only x is that you have to take 4. If it was sine x, there would be two values of x, because if it is positive it will fall in two quadrant, first quadrant and second quadrant. If it was negative it would fall in two quadrant, third quadrant and fourth quadrant. So there will always be two values. So whenever you have sine x or whenever you have cos x, there is always two values depending from 0 to 360 degree. But if you have sine 2x, what it means, what it implies is that you go through the value once and then you go through a complete revolution of 360 degree and go through it another time. So there would be 4 values. So 2x means another revolution. So whenever you have sine 2x, instead of 2 values you end up with 4 values. Whenever you have sine 3x, instead of 2 values you end up with 6 values. This is what it means. You just keep on adding 360 degree to it. So let's do an example which clarifies this. Let's start with sine 2x equals to 1 by square root of 2. So since it is positive, it would be in the first quadrant and it would be in the second quadrant. So the basic angle again is 2x. You cannot break it. Just like in compound angle we didn't break this, you cannot break this. So this would be sine inverse of 1 by square root 2, which would be 45 degree. So if you take a look here, so this is sine, by the way 1 by root 2 and root 2 by 2 is the same thing. They're just in the rationalized format. So you can see that this is 45 degree. I recommend you memorize the common angles. So 45 degrees. So this is first quadrant 45 degree. This is second quadrant 45 degree. So 2x, you cannot break this. This is the basic angle. So first quadrant 45 degree and 2x, second quadrant, this is the first quadrant, this is the second quadrant, 180 degree minus 45 degree, that would be 135 degree. So in a regular sum, if it was x, 2 of the values would be done, but since this is twice x, we have to go another circle all the way back again. So it would be from here we'll get another set of values. 2x equals to 45 degree plus 360. That would make it 45 plus 360. That would make it 405 degree. 405 degree. And from here we'll get another value that would be 135 plus 360. You see, all the way around again. That would be 135 plus 360 degree, that would be 495 degree. 495 degree. So we are done. Instead of 2 values we are getting 4 values because of another revolution. So x equals to, so 45 divided by 2. At the end we break this down. 45 divided by 2 is going to be 45 divided by 2, 22.5. 22.5. 135 divided by 2, 135 divided by 2 is going to be 67.5. 67.5. All is within the range of 0 to 360 degree. Then 405 divided by 2, 5 divided by 2 is 202.5. 495 divided by 2, 495 divided by 2, 247.5, 247.5. So we have four values. So whenever you have multiple angles, remember we have twice x or thrice x. Usually twice x is given, and you do the sum, you take the twice as the basic angle, and then you add 362. Instead of two answers, you get four answers. In case of compound angles, whenever you have something that is added, something is added or subtracted, it could be x or it could be twice x, it could be anything, but whenever something is added or subtracted, we call that compound angle. Again, in compound angle, you get the basic angle and keep it intact. You break it down at the end. We are almost done in C2 trigonometric solving questions. There's one more sum that we have to use, the trigonometric identities. This is the fundamental identity. Sine squared x plus cos squared x is identical to 1. These three lines represent that this is exactly equal to this. From here we can get two more identities, which is sine squared x is equals to 1 minus cos squared x. So instead of sine squared x, we can write 1 minus cos squared x, and instead of cos squared x, we can write 1 minus sine squared x. You can actually verify this using the most common angles. If you take this 3 and if you plug in the values, you will see how this thing works. For example, if I consider sine 30 degree, so sine 30 degree is half, so sine square is half squared, plus cos 30 degree is root 3 by 2. So cos 30 degree is root 3 by 2, so root 3 by 2 whole squared. So that would be 1 by 4 plus 3 by 4. If I add, that would be 1 plus 3, and that would be 4 by 4 equals to 1. So sine square of any value plus cos square of any value has to be equal to 1. So this works. Another thing, we could take something else. We can take this value 60 degree. So sine 60 degree is root 3 by 2 and cos 60 degree is half. So you see the same thing happens. And if we plug in any value, even if we take 90 degree, we will see that sine 90 degree is 1, so 1 square plus cos 90 degree is 0, 0 square, 1 square plus 0 square is 1. So this is sort of in arithmetic, using the values, if you plug it in, you will see that this identity holds true. Now there is another identity. This is the fundamental identity. There is another identity called sine x divided by cos x is identical to tan x. That means whenever you have sine x divided by cos x, it is equivalent to tan x. Let's check from this arithmetic whether it actually works with the common angles or not. So if we take sine 90, sine 90 is 1 divided by cos 90 is 0, so it means 1 divided by 0, and we know 1 divided by 0 is sort of undefined. We can also write it as infinity. This symbol means undefined. So and tan theta, tan 90 degrees, undefined. We cannot calculate it. We can try something else. Sine 30 by cos 30. Sine 30 is half. Cos 30 is root 3 by 2. So half divided by root 3 by 2. So what happens is half and this half cancels. So 1 by root 3 is left over, and we can see the tan theta is 1 by root 3. This thing is nothing but rationalized version of 1 by root 3. We can rationalize it. Remember, in C1 we multiply root 3 by root 3 upstairs and downstairs. So 1 into root 3 is root 3. Root 3 into root 3 is 3. So it is the same thing as root 3 by 3, rationalized version of 1 by root 3. So you have to sort of remember that whenever we talk about identities, we are talking about something that can be done and checked by arithmetic. So when you see questions regarding trigonometric identities, one of the most common type of question is this one in the exam. Suppose you have root 3 sine x minus cos x equals to 0. For doing a sum like that, you have to use the trigonometric identities that sine by cos is tan. Otherwise this cannot be solved, because there is no square that you can use 1 minus cos square or 1 minus sine square. So it's obvious this fundamental identity cannot be used. You have to use sine by cos. So what you have to do is square root of 3 sine x equals to cos x. So we can write sine x by cos x equals to 1 by square root of 3. So sine x by cos x can be written as tan x 1 by square root of 3, and then you can solve this. So this is one example. Another example could be, we can get 5 sine x equals to 2 cos x. So again we can write sine x divided by cos x equals to 2 by 5, therefore tan x equals to 2 by 5, and then this can be solved. So whenever you have sine x and cos x, using the trigonometric identity that sine x by cos x is identical to tan x, we can actually solve this sum.